Good morning, everyone. Thank you for coming to our session despite the early hour. And so first of all, we really appreciate that the Code Blue Committee gave us this great opportunity of sharing our findings and insight with Code Blue audience. We are very happy if we contribute to the Code Blue conference through our presentation. Okay, the title of this presentation is "Did Subdomain Abuse by BlackTech Evolve?" Before we move on to the main part, let us introduce ourselves. My name is Tsuyoshi Taniguchi. I'm a researcher at Fujitsu Defense and National Security. My interest is network security and detection of malicious behavior around DNS. And I was a speaker of many InfoSec conferences, including BlackTech Code Blue and BlackTech Asia Briefing, Asia CCS, and HitCon Enterprise recently. And this is my sixth presentation in a Code Blue conference.
Hi, I'm Kotaro Ohsugi. I'm also working at FDNS as a security researcher. I was once an analyst in digital forensics field, and now my main focus is reverse engineering. Today, I will give you a brief introduction about BlackTech and their malwares. And then after that, Taniguchi-san will explain further. Okay, so today we're going to talk about BlackTech. But first, who are they? What kind of threat are they? Well, they are a Chinese cyber espionage group. They target mainly East Asian countries. As you can see from this figure, Japan as well. Last year, National Police Agency of Japan and US agencies warned of their capability to compromise headquarters in Japan from international subsidiaries. So they can be our real threat. And by learning about their activities, we can prepare and prevent their future attacks. Actually, like security vendors have released many excellent reports when it comes to their malwares. But what about their DNS activities? Literally, there's no report. This is our main topic today, and we'll talk about it later. But first, let's take a look at one of their malwares called debugprint, also known as WaterBear. Here's its timeline. It said that it was already active in 2009. And in 2019, Trend Micro reported a new feature using API hooking. In 2020, Team T5 shared a detailed analysis at JSAC 2020. By the way, this is an amazing report and must to read, if you, analyze it. Then in 2021, Unit 42 disclosed its internal configuration. And in 2022, it said that it evolved to DutyBear, another variant. So next, let's move on to its detail. It typically consists of three components: launcher, downloader, and RAT. Here, the downloader is the hardest one to analyze because it utilizes the full of obfuscation techniques. For example, some functions are decrypted and encrypted on the fly. So we need to be careful when we set breakpoints, as they write a hex value CC, and that can that can make the ciphertext totally meaningless. And it also uses bitwise NOT to hide important information, such as domain names. And surprisingly, it even implemented its own challenge response feature using modified RC4 encryption. This can help debug print to distinguish fake city servers from legitimate ones. And this isn't over. There's one more thing. It said that, as I told you, it evolved to another variant, Doodlebear. And now it uses HTTPS, which makes analysis even harder. Also, new anti-analysis features were implemented. So, as a conclusion, analysis can be hard due to its sophisticated implementations and continuous evolvement. Okay, so we showed how sophisticated the malware is. And did it evolve? Yes. Yep. It equipped to it evolved to Doodlebear, equipped with HTTPS and some brand new anti-analysis features. But regarding their DNS activities, maybe they're slack enough. For instance, they often reuse their parent domains in their campaigns. Why is this a bad practice? Well, now Taniguchi-san will explain further.
Thank you, Ohsugi-san. And at the end of the introduction, we would like to explain our contribution. As Ohsugi-san explained, BlackTech certainly evolved their LAT tool to make analysis harder. How about DNS abuse? Security vendors did not pay attention to. And could you please remember the title of this presentation? We will show the answer to the question at the end of this presentation. And we would like to contribute to show our findings and insights based on our analysis. And we will show we will share the know-how of data forensics for APT attacks. We made use of cyber threat intelligence, passive DNS, and WHOIS database. We will show the way of making use of these datasets. And we try to apply our proposed technique to find valuable information. Okay, as we explained, we will do a deep dive into the relation between evolution and strategic change. Then we fast track the changes of attack method over time. And this approach is not new. Many security vendors and researchers have tracked changes of attack method. And in this presentation, we call this approach time-based change detection. And next, we detect differences of attack methods among APT groups in the same time period. We call this approach a comparison-based difference detection. The most feature of this approach is to combine the time-based type change detection with the comparison-based difference detection. This means that we try to identify original operation based on the strategic change. And from next slide, we will organize the types of subdomain abuse for C&C communication. very few researchers organize types of subdomain abuse. Then this is one of features of our approach. So we will do a deep dive into the combination of original operation and strategic change from subdomain abuse viewpoints. Okay, in order to conduct comparison-based different detection, we mainly made use of threat vision by CB25. We first would like to express our appreciation for the continued cooperation by CB25. We selected this 8 APT group since we confirmed regular activity by these APT groups. And we used flash reports, and the flash reports described targeted countries, targeted industries, tools, tactics, techniques, and procedures, and indicators of compromised IOCs. We extracted IOCs from January 2022 to March 2024. This is a ratio of targeted countries for each APT group. This graph represents that BlackTech mainly targeted Taiwan. We aim to analyze APT attacks targeting Taiwan for defending against future attacks targeting Japan. Okay, let us confirm the way of communicating with CNC servers. As you know, malware must identify the IP addresses of CNC servers for CNC communication. The most simple way of identifying IP address is to embed IP addresses in malware. However, if defenders identify the IP addresses, the defender can easily block CNC communication. Therefore, adversaries often abused DNS for changing IP addresses. And basically, adversaries abused domain names for CNC communication, and we had to investigate whether APT groups abuse subdomains or not. Okay, this is the ratio of IOCs for CNC communication. Menu paths and Polaris still used IP addresses for CNC communication. And Kim Dragon mainly abused dynamic DNS services or rate-limit services. And half of APT groups abused subdomains. In particular, BlackTech abused mainly abused subdomains. Okay, before we explain the types of subdomain abuse for CNC communication, we would like to give a rough explanation in order to promote your understanding. In a case where APT groups register their domain names, they can conduct two types of operation. The first type is subdomain operation, and the second type is parent domain operation. In a case of the subdomain operation, APT groups can abuse any strings in subdomains as much as possible, as much as they would like to. For example, they can abuse a string related to real organization like JP-cert or TW-cert. In addition, they can use parent domains for many subdomains. In a case of parent domain operation, they can operate parent domain regardless of the subdomains. For example, they make their domain names dormant during a few years after the registration in order to evade the detection by aging filters. Aging filters mean the filters detect fresh domain names. Fresh domain names. Defenders know that fresh domain names are suspicious. In addition, they can abuse subdomains while the parent domain dormant. In this case, they set the parent domain no A records on purpose. We divided subdomain abuse into 3 types, including subdomain operation and parent domain operation. And we first would like to explain legitimate service abuse. In 2018, BlackTech abused dynamic DNS services. Most of subdomains were related to dynamic DNS abuse. Okay, the second type is subdomain operation. We would like to explain string abuse and reused parent domains in turn. Domain owners can operate any strings in subdomains. Then, phishing attackers often abuse brand names or legitimate URLs in subdomain. On the other hand, APT groups rarely abuse brand names. However, BlackTech abused strings like JPSAT and TWSAT-CC as subdomains for CNC communication related to TS cookie in 2018. This slide explains the reused parent domains. Domain owners can operate subdomains as much as they like without any limitation. The merit of this abuse is to omit registering domain names. In this example, malicious actor mapped 3 subdomains to the same parent domain. And based on an in-depth analysis of reused parent domains for APT attacks, we identified 2 types of reuse. The first type is reuse for single target, and the second type is reuse for multiple targets. The starting point of analyzing subdomain abuse is our presentation in Codeblue 2021. We presented the way of searching subdomains for parent domains from passive DNS database. We found abused brand names from we found abused brand names in subdomains for PAC domains. In spring 2023, we applied this approach to find subdomains related to APT attacks. In short, we extracted parent domains from abused subdomains in the threat vision. Then we monitored newly mapped subdomains for the extracted parent domains. After that, we investigated whether the newly mapped subdomains were related to APT attacks or not. Unfortunately, in this point, this approach could not work. However, we waited and saw for a while, and since September 2023, BlackTech reused their parent domains for multiple targets. Therefore, we considered a way of distinguishing reuse for single target from reuse for multiple targets. Okay, this is a way of evaluating reused parent domains. Basically, each flash report corresponds to each target, and in order to identify reuse for a single target, we extracted reused parent domains from IOCs in each flash reports. In order to identify reuse for multiple targets, we identify reused parent domains among several flash reports. Okay, the third type is parent domain operation. We would like to explain strategically aged domain and fake demand, fake response. Okay, researchers of Palo Alto Networks found that dormant domain name during 2 years after the restoration abused for SolarWinds supply chain attack in order to evade the detection by aging filters. They call this type of abuse strategically aged domains. We would like to evaluate the aging period for APT attacks. It is difficult to evaluate the aging period. This is because we did not identify the exact date when the APT group started attacking. We certainly investigated the date of restoration from WHOIS database. And when the flash report was published, the APT group should have started attacking. Therefore, we evaluated the elapsed time from the date of restoration to the date when the flash report was published. Please note here that our evaluated aging period is a little long compared with the exact aging period. And this slide explains the fake dormant. And APT groups can operate subdomains while its parent domain remains dormant. In this case, they set the parent domain or no A records on purpose. Why fake dormant? Let us organize the relation between subdomain and its parent domain from malicious judgment viewpoint. If a parent domain is malicious, then its subdomains are also malicious. This is because only domain owners can operate subdomains. On the other hand, if a subdomain is malicious, then its parent domain is not always malicious. This is because if the APT groups abuse dynamic DNS services, in most cases, the dynamic DNS services create accounts as subdomains. Therefore, only subdomain is malicious, and the parent domain is legitimate service. And APT groups can abuse subdomains while the parent domain remains dormant. And we confirm cases where the subdomain was detected as malicious by security vendors. On the other hand, its parent domains were not detected as malicious by any vendors. It was worth hiding their parent domains for their next attacks. And we would like to introduce the countermeasure against fake dormant. We would like to introduce additional active DNS. We abbreviate additional active DNS as AADNS in this presentation. And we have already published AADNS in HitCon Enterprise 2024. Our idea is very simple. In a normal case, a client accesses the subdomain, and the client sends a query regarding a subdomain to a caching DNS server. Our idea is to add an additional query regarding a parent domain of the subdomain to an original query regarding a subdomain. If the client receives only subdomain response, the client can identify that fake dormant is abused. And this slide explains fake response. BlackTech mapped IP addresses by Amazon or Google to their parent domains. On the other hand, they mapped IP addresses by other providers to their subdomains. And they did not use their parent domains for their attacks. they might lead to misunderstand that their parent domains were operated as legitimate services. Unfortunately, in this case, AADNS could not work. And this is a way of evaluating fake demand or fake response. We made use of name resolution history from passive DNS. And it should be noted here that there were not all name resolution histories of subdomains related to APT attacks. Therefore, only if there were subdomains in passive DNS database with such name resolution histories of parent domains. In addition, we made use of IP geolocation, and this is because it was worth investigating providers of IP addresses of parent domains. Okay, let's move on to the main part of this presentation. We would like to the time-based change detection. As you know, cybersecurity is a game of cat and mouse. So adversaries always try to evade the detection by defenders. So if the adversaries change their strategies, so that they have any intention behind the strategic change. Therefore, many security vendors and researchers have tracked changes of attack methods. In fact, in our Kotaro 2022 presentation, we have tracked malicious activities by adversaries who hide IP addresses of C&C servers in Bitcoin blockchain. One of the features of this approach is to detect changes of subdomain abuse. Very few researchers pay attention to the subdomain abuse. In fact, in our Kotaro 2020 presentation, we have already analyzed the IOCs related to BlackTech. However, we have not analyzed from subdomain abuse viewpoint. We brushed up on the analysis. And could you please remember the title of this presentation? We would like to do a deep dive into the relation between evolution and strategic change. We designed to combine the time-based change detection with the comparison-based difference detection. We will explain later. And we made use of blogs by JP Tsuyoshi, flash reports from Threat Vision by CB24, and blogs by Trend Micro. We combined commercial CTI with the Oshinto. Okay, let's look at the evaluation result in turn. BlackTech stopped abusing dynamic DNS services. Then they registered their domain names. This strategic change enabled BlackTech to operate both subdomains and parent domains. In fact, they strategically registered their domain names since 2019, like this. They registered several domain names every year, and then they abused subdomains for these domain names since 2023. And the most characteristic change is that BlackTech reused their parent domains. In 2018, they did not many reused parent domains. On the other hand, they actively reused their parent domains for multiple targets. In this table, this column represents the domain name, and this column represents the date of restoration. And these columns represent the status of reuse. And let's look at these two. This table shows most of parent domains were reused for multiple targets. And interestingly, we confirmed that parent domains from CB24 were overlapped with ones from Trend Micro. In this table, yellow-colored area represents subdomains from blogs by Trend Micro. And this is the evaluation result regarding fake demand or fake response. And there were no big changes regarding fake response. BlackTech basically mapped IP addresses to their parent domains. However, interestingly, in the debug print campaign, they first abused fake demand. Fake demand means they map no error code to their parent domains. After that, they mapped IP addresses by Amazon or Google to their parent domains. Okay, we organized the relation between status of reuse and fake demand or fake response. In this table, this column represents the status of reuse, and this column represents the fake demand or fake response, and this column represents the number of vendors judged malicious in BIOS total. And let's look at these two parent domains. In a case of reuse for single target and fake demand, no security vendors could detect these two parent domains as malicious. On the other hand, a case of reuse for multiple target and fake response, many security vendors could detect these parent domains as malicious. Defenders have more opportunity to detect when BlackTech used their parent domains for multiple targets. And we would like to explain the comparison-based different detection. So in our Codable 2017 presentation, we presented a way of comparing indicators among attack groups in order to extract variable or indicators from a lot of disposable ones. And recently, APT groups sometimes share common tools. However, all APT groups did not always conduct the same DNS operation. Therefore, we tried to apply this approach to detect differences of attack method among APT groups. And we would like to distinguish majority from minority. In other words, we distinguish standard operations from original operation. And before we show the original operation by BlackTech, we would like to show the original operation by APT group other than BlackTech. Lazarus abused domain names several months after restoration. This operation was same as the short-term attack, like phishing attack or botnet. And this type of abuse was detected as by aging filters. On the other hand, most of APT groups abused strategically aged domains. We consider that strategically aged domains was a standard operation in recent APT attacks. Okay, this is the original operation by BlackTech. So BlackTech actively used their parent domains for multiple targets. In this graph, red-colored area represents reuse for multiple targets. And APT groups other than BlackTech did not use their parent domains for multiple targets. Therefore, BlackTech prior to efficiently construct their attack infrastructure. And this is the evaluation result, the fake demand or fake response. In this graph, red-colored area represents fake dormant, and menu pass, amoeba, and dirty fixie abuse fake dormant. And we confirm that 3 parent domains by menu pass and 2 parent domains by dirty fixie were not detected as malicious by any vendors. On the other hand, BlackTech mapped IP addresses by Amazon or Google to their parent domains. Although they might lead to misunderstand that their parent domains were operated as legitimate services, as a result, many security vendors detected their parent domains as malicious. Okay, this is answer slide to the question. This subdomain abused by BlackTech evolve. Based on our in-depth analysis, BlackTech stopped abusing dynamic DNS services and they registered their domain names. This strategic change enabled BlackTech to operate both subdomains and its parent domains. In fact, they registered several domains every year since 2019, and they mapped subdomains for the registered domain names since 2023. On the other hand, they did not they did not use their parent domains for their attacks. They mapped their IP addresses by Amazon or Google to their parent domains. They might lead to misunderstand that their parent domains were operated by as legitimate services. And the most characteristic change is that BlackTech used parent domains for multiple targets. And APT groups other than BlackTech did not use their parent domains for multiple targets. And we consider this operation as original subdomain operation by BlackTech. And we consider that this strategic change was not evolution for detection evasion. They prior to efficiently construct the attack infrastructure, and we guessed that BlackTech made efficiently use of strategically edged domains, since it took time to prepare for the strategically edged domains. And finally, let us organize the subdomain abuse by BlackTech. BlackTech strategically registered their domain names, then used the strategically edged domains for multiple targets. If defenders identify the abused parent domains, the defender can easily detect abused subdomains for the parent domains by monitoring the parent domains. If defenders are not identify the parent domains, it might be a good idea to investigate parent domains of subdomains detected as malicious in VirusTotal or not. Okay, let us summarize our talk. The starting point of this presentation is this subdomain abuse by BlackTech evolved. Based on excellent reports by many security vendors, BlackTech certainly evolved their LAT tool to make analysis harder. According to the blogs by Trend Micro, BlackTech evolved their LAT tool from WaterBear to DutaBear. Based on in-depth analysis, we consider that the original subdomain operation based on the strategic change by BlackTech was not evolution for detection evasion. They prior to efficiently construct attack infrastructure to utilize strategically edged domains. So recently, cyber attacks are business, so APT groups did not always prior to evade detection. Therefore, defenders could catch APT groups, including BlackTech, off guard. So in order to detect the weak point by APT groups, it is essential to conduct an in-depth analysis of tactics, techniques, and procedures, including DNS abuse, in particular, subdomain abuse. That's all for today. Thank you for your attention. We hope that our findings and insight help security people in Japan. Thank you.